Hello everyone, today we're going to talk about characteristics of graphs. So if you would, please pause the video and copy these vocabulary terms down for characteristics. Again, pausing the video to copy down the rest of the characteristics. Looking at example 1, we have this graph that appears to be a quadratic or a parabola that opens up. And so we want to find all the characteristics on the right side in interval notation. So starting off with domain, we want to look at this left arrow. So this left arrow tells us that we're going to continue in this general direction of going up and to the left. And since it's going up and to the left, that left portion means that on the x-axis, we're going all the way to negative infinity. It looks like it's going to be very steep, but it will continue going to the left. So our domain, our lower bound, is negative infinity. And then for the same reasoning, our right arrow is going to continue going up and to the right, all the way to positive infinity on our x direction or x-axis. And so our domain is going to be all real numbers, or in interval notation we have to write negative infinity to positive infinity, and again we have to have parentheses on that. For our range, we're going to look at a very similar idea, but for our y-axis. And so negative infinity is all the way down here on the y, and the positive infinity on the y is up here. So we will never reach negative infinity in the y, because our lowest point is on the parabola on the vertex right here. And so that's going to be our smallest point or our lowest point. And our range will always go bottom to top. And so our range, our smallest value is that 1, because that 0.41, so the y value is 1. And we do have an actual point there, so we're going to include it in a bracket. So we're going to have bracket 1. And then as I said earlier, these arrows tell us we continue going up in both arrows tell us going up to positive infinity in the y. And so we're going to have positive infinity as our upper bound on our range. For intervals of increase and decrease, we need to talk about in terms of the domain. We need to cover the entire domain. If you remember from the slides before, that the intervals of increase and decrease are based off of x values. And so we want to look at the furthest left we can go, which is this arrow right here, which in this case we're going to represent as x is negative infinity, because it's meaning that whatever's happening at negative infinity is going to continue doing that and doing it all the way through here. So we're going to continue. So this function is going down, because we always read this as we go from left to right. So we're going down from negative infinity until we get to this x value of 4. So we're using an x value right there. So that means we are decreasing from negative infinity until we get to 4. Again, at negative infinity, we're going to have a parenthesis. And at 4, at this point, we are technically at flat ground, so we are not decreasing or increasing at that moment, so we're going to have a parenthesis on that. So that's going to be always true for increasing and decreasing on a quadratic or parabola format. And so then at that value of 4, we start going up, and we're going to increase, and this arrow tells us we're going to continue going until positive infinity on the x. And so that means our interval of increase is going to be from 4 all the way to positive infinity. And for the same purposes, we have a parenthesis on the 4 as we talked about for decrease. For maximum and minimum, you can revert to the graph or revert back to the range, because we know that the max is the largest value in the range, the min is the smallest value in the range. And so looking at that, just reading our range from left to right, our our minimum or lower bound was 1, and we have a included 1. So we should know that that's going to be our minimum, and we only include the y value. On the upper bound of the range is positive infinity, and we don't actually reach infinity because we can't reach infinity. We can keep going on forever. And so that for that purpose, we're going to have no max. We do not put infinity here. We're just going to put none or NA. For your end behavior, you're looking at as we go to negative infinity on the x, which means this left arrow right here, we are either going up, down, or to a number. And so since we're going up, we're going to put that we're going up to positive infinity in this case. And as we go to the right arrow, which is this positive infinity, we are talking about this right arrow. And that means that we're also going up to positive infinity. Now for rate of change, you're going to use these values right here as your x values. So you want to think that this is your x1 and this is your x2. And we have these points 2 comma something and 4 comma something that we need to use the graph for. So at 2, we can find on our graph that we have this point 2, 5. So we could fill that in. And at 4, 1, which we already talked about before, we have this point there. And you can label those x1, y1, and x2, y2, and use the formula that was on the second slide. But if you're given a graph, it's much easier just to say rise over run. So we would rise down 1, 2, 3, 4, and we run 2. And so we rise -4, we run 2, and so that would be -2. And if you want to pause the video and do the formula with these points, you will get the same value. For number 2, we have a parabola, or I'm sorry, an exponential. And so we want to recognize that on this exponential, that we're going to have this asymptote. It's not going to be written in for you, so you want to make sure that you do write these in just for your visual purposes. And so what that means is that's going to reach, or it's going to get very, very close, but never reach the asymptote. So we're going to get super close to -3 on the blue line, but never actually reach it. And so for domain, we look through the same kind of way. How far to the left do we go? So over here. And then that would be how far to the left for our lower bound and how far to the right for the upper bound. So this arrow down here tells us we're going to continue going down and to the left. So that means as we're going down to the left, that we're going to continue going to -infinity for our lower bound. And as we go to the right over here, we're going to continue going to the right to +infinity. So again, we have all real numbers, but we need to write it in interval notation. For our range, we look at this arrow and we say how far down do we go on the y-axis. And so for our y-axis, we have -infinity down here, and we have +infinity up here. So this arrow tells us we're going to continue going down, and so we're going to go down to -infinity, so that's our lower bound. And then our upper bound, we see that this is going to get closer and closer to -3, but it's never going to reach that asymptote, even though I just erased it. It's never going to reach that asymptote, so we're going to get super close to -3, but never reach it, so we're going to have an open parenthesis on that. So it's very important to make sure that you pay attention to that, because all exponentials with an asymptote will look very similar with the range. Whatever one of those values is always going to be open on that. For increase and decrease, we kind of look at how we did the last one. And so remember that we're talking about our x values. And so as we go from the left side, this left arrow tells us that we are talking about from when x is -infinity, and we are going to the right, and that's going up. And although it looks like it flattens out, we are getting super, super close to -3, but never actually touching it. We're going to continue to get closer and closer, which means we're going to continue to go up. And so we are going to be always increasing on this problem. So we're going to increase for all real numbers, or for the entire domain, or for -infinity to +infinity. And if we're always increasing, then there's going to be no interval of decrease. For maximum and minimum, we can refer back to our range again. So our range says -infinity is our lower bound. So for the same reason we talked about in the last one, that means we do not have a min, so we put none. And for the upper bound, what you want to look at is, do we actually reach -3? So we do not reach -3, so therefore we do not have a max. And that's going to hold true for exponentials when we're looking at them in this format. For end behavior, again, we want to look at, this one means the left arrow, which is right there. And that arrow is going down, so we're going to say -infinity. And then the right arrow, or +infinity, that is approaching our asymptote, so we're going to say that the y value there is -3. We're approaching -3. We're never going to reach it, but we are approaching it is what we're talking about there. And then for our average rate of change, we know that those are our x values. So this is x1, x2. So at -2, we have this value right here, which is at -9. So we could write -2, -9. And then we also have 0, in this point -4. Again, you could write x1, y1, x2, y2, and solve using the formula. Or we could just say, let's do rise over run. So from here we rise 1, 2, 3, and we run 1, 2. So we have a rate of change of 3/2. So I hope this helps, and make sure that when you're going back for your work that you are always including your answers in interval notation.